Okay, hello everyone. Thanks for coming around. This is the second part of the track on measurement and performance. A quick recap of yesterday. It was about recent results and studies that we have done with members of ProbeLab and others and collaborators of ours. Today, it's going to be more like an interactive session where we are going to look into the future and what we want to do in the coming quarters. So I'm going to start the session by talking about some of the milestones that we have, giving a brief description, and then the floor is going to be open for everyone to either suggest new items or, let us know other areas of interest. What we're then going to do, we're going to have another talk that came in the last minute by a colleague that just joined, and he's very interested in letting us know what they're working on. And then we have a bunch of breakout sessions. They are on the website, on the IPFS Camp website. The timings are a little bit messed, so don't pay attention exactly to the timings. They're going to be 45 minutes each. And we'll use the tables basically to, have two at a time in parallel. We can, well, when I finish that, we can, when I finish that, we can vote if we want to drop some session. We can do it. If we want to have an additional one that someone has to propose, we can do that as well. So today it's really time to get involved and, influence what we are going to be discussing until, the next 3 to 4 hours, until 5, 6 o'clock. Okay, so that's the brief logistics for this afternoon. So I'm going to start with, with going through the milestones that we have prepared. The first one is about the Hydras. So we had a talk yesterday by Dennis on some results on whether Hydras are providing value in terms of performance to the network. And as you understand, this is an ongoing study. The milestone that we want to reach is be able to answer the question of whether Hydras are needed in the IPFS network, what performance improvement do they bring, in several different situations. So that is going to be the end goal of that. Pretty important in my opinion. Now, we also went through and referred to several tools that we're using. Primarily, it has been the crawler, the Nebula crawler, but we have, Mikkel mentioned the CID Hoarder, which we used for the provider record liveness study. So we do have several tools we use to do the active and passive measurements in the network. What we want to do next is set up some continuous measurement infrastructure or continuous monitoring infrastructure with a more sexy name we need to come up with. But what we want to do is have those deployed, get the tools. As I mentioned, all these are already open source. They are documented. People can use it. It's just they're scattered around. They are not in one place. So what we want to do is have do the instrumentation so that all these tools live in kind of one place under perhaps one organization in GitHub or something. There is a backend where they're deployed. They run continuously the experiments. Some of them might be running really continuously, like every, few minutes or so. Some others will not make sense to run so frequently. So the kind of periodicity is going to be different depending on what the script and the experiment is doing. And then feed all the results that we have in a kind of data lake or data warehouse where we collect everything and then we have the right tools to analyze the results and give out the plots or the dashboards or whatever we want to have as a front end. That should be easy to consume by the users, by the ecosystem, but it should also be easy to reproduce and use from others for their own purposes. We do have another one that I kind of briefly touched into when I was talking about the DHT lookup latency, well, the retrieval latency more generally, which is the Bitswap provider delay, where if you remember in the plot, what happens in IPFS is that when a user is asking for some content, they go and ask their immediately connected peers. And they wait for 1 second to receive a reply back, and if they don't, that's when they go to the DHT and try to resolve the content through there. So this means that if content is popular and it is within the swarm of a peer, then you've got the chance of getting responses very quickly. But if not, which could be the vast majority of content, perhaps, I don't know, then you're waiting for 1 second and the success rate is very low. So in that case, you're just waiting for 1 second for no good reason, and only afterwards you go the DHT. This is an ongoing kind of set of experiments that we're doing with, yeah, somewhat controversial results, you would say. Results that at least we cannot really explain 100% right now. But basically, the target of this milestone is to say, is it worth having Bitswap ahead of the DHT lookup in the retrieval process? Yeah, we call those magic numbers. They are fixed in the IPFS and libTP code base. So the bigger project is kind of clean up those magic numbers, have a more rigorous kind of investigation of whether they're set correctly. Ideally, if we can have non-magic numbers, but parameters that adjust dynamically based on something, on the network load, on the node load, well, depending on what the thing is, that would be great. It would make, you know, everyone's life much easier. You won't need to go and be checking periodically, is that now that the network size doubled, is it still the right parameter? You know, so that's a part of a bigger project that we have. Another one, another one that we have, that we pretty much, the project is complete, but we just need to do the final touches, is on the provider record intervals, the expiry, provider record expiry intervals, and provider record republish intervals. That, again, Mikhail presented very in great detail yesterday. So we do have some new recommendations for the engineering teams, and it's a matter of basically, including those in a new release. But most of the work has been done, which is great news. We already have a box to tick. Then we have another colleague of ours that is not around in Lisbon these days. Is called Thunderdome. We might get lucky and have a pre-recorded video by him saying what Thunderdome is. It's a very useful tool. Again, of course, it's open source, but what it does in brief is that it is instrumenting a node, trying to replicate the IPFS gateways. But yeah, more generally, it's an IPFS, a kubo node, basically. And you can use that to interact with the network and set up, you know, tests and experiments you want to do in an easy way. And interact with the network. It also replays the traffic from the gateways, but okay, of course this can change. So it's pulling the stream of requests from the gateways and it's replaying that through the node, so that you can have a, in some cases, realistic, you know, traffic load that that is being done with the experiment. Which is useful in some cases. Now, what we want to do with this one, of course, it's very interesting more generally for measurements, and we're using it already. But what Ian wants to do is to have it test automatically the new releases of IPFS, so that you can check for any regression that, you know, the IPFS team wants to push out, and check if everything is as expected, basically. So. Yeah, this is done, but somewhat manually. We want to have it that as part of the of our infrastructure. Then we have this study that is called Optimistic Provide. We didn't present that. If you're interested, we can point you to several very detailed documents that we have, or you can talk to Dennis. It's right here. But what this study does is that, as I showed yesterday, the provide process, when someone wants to publish content in the IPFS network, is very slow. It takes tens of seconds and sometimes hundreds of seconds. This is because of the internals of how IPFS works. That's out of scope for this particular presentation. But what we found out is that you can optimistically kind of choose which providers you want to pick to store in order to store the provider record with. And once you choose them, you can like preemptively finish the process. And that will complete much faster, much less than tens of seconds. So this is also developed. It's close to being finalized. We do have results that are very, very encouraging, so to speak. And we've tested also, comparatively with other approaches of how could it possibly be done. And yeah, there is a kind of robust study behind that. So the next step with that is to test a little bit more, do some other things that I'm not aware of because they were discussed just a few days ago, and basically put it in an experimental release before it goes out more generally. Another magic number is the DHT timeouts. There are several boards in the DHT, while walking the DHT to do several different things. So that's one study that will potentially can increase performance a lot, because in many cases you might have experienced that some things are just hanging forever. You start requests that never finish and you just hang there forever. These could be small, easy wins and low-hanging fruit, so to speak, on, if something is not working, just kill it early and restart the process. It's going to be much faster anyway. So a very interesting study. We haven't started on that. And it will require lots of digging into the internals of how the DHT works. The nut hole punching, there is a talk tomorrow in the Lip2P day about nut hole punching and how it works. The Lip2P team has put out a very interesting technique to overcome this eternal problem in peer-to-peer networks. And what our team kind of is offered to do is measure how successful this can be. Having a solution is a different thing to having a good solution. So we're not questioning anything. It seems that it's working very nicely. But again, more testing is needed. Reminder on this, you should sign up and become part of this experiment. If you scan this QR code, then you're going to be redirected to this form, the sign-up form. And the experiment, we're expecting to have it during December, pessimistically for a week, optimistically for a month, we'll see. You'll be asked to basically download the binary, which is going to show up on your taskbar there, like that, and indicate when it's running and when it's not. And from the infrastructure that we have built, we are going to be attempting to do, to connect to your node from the outside, from other networks. So it's very interesting. It's going to give us lots of results, but for this, in order to get as many results as we can, it would be great to have as many people running it as we can. There is documentation. This is the GitHub repository there, I think. No, that's not it. But yeah, anyway, there is links to the GitHub repository of how everything is instrumented. Obviously, it's all open source, so you can check internally what it's doing. And it's going to be great to have this experiment running. So with that, we're hopefully going to land this milestone of being able to say, it succeeds with this much percentage points. Quite likely we'll need a follow-up study on that if we need to do any optimization, but that's the initial target that we have. Another one on Lip2P privacy guarantees. It has been mentioned a few times, even during the morning session, and there is tomorrow the entire afternoon is on Lip2P privacy. So come along there to see what we have been working on. There is an approach that is called double hashing, and we arrived to that after doing quite a bit of research on, what would be the best thing to do as a first step. There is no one size fits all for privacy, even in like protocols that we use today, and even more so for decentralized protocols that are based on DHTs and PubSub and peer-to-peer and so on. So we chose that approach of double hashing. Again, there is a super detailed document about how it works and what we should do and what we are going to be doing. So we can link you to that if you want. But yeah, come along to listen to what it means. And we have started, the development work is pretty close to completion, at least some parts. A tricky part there is the transition, like how, because there are some kind of non-backward compatible changes, or someone could do it this way. How it's going to land to the existing DHT network is not very, it's not very clear right now. So there are some challenges there, ongoing discussions. Get involved if you want, if you have other ideas. But exciting work. What else? Yeah, we have lots of things. So we want to focus on Gossipsub as well. Gossipsub is one of the protocols in the libp2p stack. It's the main PubSub protocol, I would say, although there are others in the libp2p library. Now, the interesting thing is that Gossipsub is used in the Filecoin blockchain in order to transfer the blocks around from one storage provider to the other, well, to everyone. So it's pretty central that it works as expected, and that's what we want to measure, basically. We want to go down and do all the instrumentation that is needed in order to see, when one storage provider is publishing a new block, how soon after has this propagated to the rest of the network? That's one very basic thing that we want to do, that we need to do. The second thing that we want to do is see if the security properties of Gossipsub are working as expected. So as you understand, blocks in the Filecoin blockchain are kind of transferring value around, basically. So if someone wants to attack the network in one way or the other, that is not going to be great news. So Gossipsub was instrumented with some security guarantees a few years ago, before the Filecoin launched. And these are with regard to a score function that works for every peer and basically kicks out the peers that seem to be misbehaving. There is a very nice, there are several talks about how this works. I can point you to them. Some of them are on YouTube to get into the details, but we want to check basically whether those mitigation strategies that we have put in the protocol, they're actually working as we expect them to work. Very important study, quite heavy, I would say. It's going to take some time, but we're going to take it step by step, and don't forget to breathe, I don't know. And that's it. That's our, I don't know, about 10, maybe 9, 10 next milestones that our team has got for the next few quarters. So, thank you very much. Any question? Yeah.